So we've seen how we can use trig ratios to find missing sides and missing angles in right triangles. So we're going to spend a couple more days working with trig ratios to find sides and angles in right triangles. Again, Friday is your test, quiz on this chapter. And then the following Tuesday will be your exam on chapters 1, 2, and 3. And we're going to have time for review. And your final exam is scheduled for Monday, June 19th. When the actual schedule comes out, the Math 10C exam will be a different day. It'll be later on in exam week, but we have to write ours a few days early because I won't be here when it's going to be scheduled. So I will be sending emails out to remind everybody about all those important dates, but the final exam is an important one that you can't miss. So we've been practicing labeling the triangle with respect to a reference angle, which is an angle that we're going to work with, and also working with the sine, cosine, and tangent ratios. We've also practiced using calculators. So we'll start solving problems using the ratios, but we will start with practicing our basic skills first. Try this again. Been acting up today. So these first questions don't really involve trig ratios, but they involve solving for a variable. And in most cases, we're going to do what we did yesterday, which is cross multiply, in most cases. So for that first one, if you want to solve for x, because the right side is a fraction, I would make the left side a fraction by putting it over 1, and then we cross multiply. If two ratios are equal, their cross products are equal as well. So 1 times x will equal 1.5 times 7.8. So in this case, by cross multiplying, we have the variable by itself. So we can just multiply 1.5 by 7.8 to give 11.7. For the second one, again, you've got two fractions equal to each other, so their cross products are equal. So 5 times x will equal 3 times 12, which is 36. And in this case, we would have to divide both sides by 5 to get x by itself. So x will equal 36 over 5, which is 7.2. So again, we did steps similar to these first two involving our trig ratios. When we wrote equations for sine, cosine, tangent, we always cross multiplied, and sometimes by cross multiplying you had the variable by itself. In other cases, there was one extra step you had to do, just like this last one that we did. Question C, I would put the 24 over 1 and then again cross multiply. So 24 times x will equal 1 times 6. And then to get x by itself, we would divide both sides by 24. And x would equal 6 over 24, which is 0.25. Now for the last one, we just have to get x by itself, so we wouldn't have to cross multiply because the x cubed is already by itself. To get rid of the cube, we do the opposite, which is cube rooting both sides. And on the right side, the cube root of 27 is 3, the cube root of 8 is 2. So the answer is 3/2. So those first three examples, we did steps very similar to when we were finding a missing side or missing angle in a right triangle by using those three trig ratios. They're on the formula sheet, so we don't have to memorize them, but you have to know how to use them. And remember, that involves labeling the sides of the triangle. The side across from the right angle is always the hypotenuse. That never changes. Because that bottom angle is labeled theta, that's the one you'll be using. The side across from that is the opposite. The third side is the adjacent side. So that's how we label the sides of a right triangle. And then the two sides that you're using, the two of those three sides, Princess, tells you what ratio you're going to use, whether sine, cosine, or tangent. So let's look at some examples. A surveyor wants to determine the width of a river for a proposed bridge. The distance from the surveyor to the proposed bridge is 400 meters. He uses a special device called a theodolite that measures angles and finds that it's 31 degrees across the river from one side to the other of that proposed bridge site. So what is the width of the river to the nearest meter? So again, I've talked about the fact that surveyors use trig ratios all the time. This would be an example of where they would do that, because they can't really string a tape measure across the river. But they can start at the point on the same side of the river where the bridge will be, and they can measure how far they move away from that, which is the 400 meters, and they can use a special device to measure the angle from that point across to the side on the other side of the river, okay, where the other side of the bridge will be. So we start by labeling the sides of the triangle. The side across from the right angle is always the hypotenuse. That never changes. Because we've got this angle to be 31 degrees, we're going to use that. The side across from that is the opposite. The third side is the adjacent side. We want to find what the width of the river is, which would be x. So we're going to use the opposite, and because we're given that 400 meters, which is the adjacent side, we're going to use that as well. In this case, we're not given the hypotenuse, not asked to find it, not going to use it. We need to write an equation that uses the opposite and the adjacent. And if we look up at the top, it's the tan ratio that uses the opposite and the adjacent. So the tan of the angle, which is 31 degrees, equals, and the order matters. It's opposite first, adjacent second. Opposite on top, over adjacent on the bottom. So the equation must look like that. We'll make the left side a fraction so we can cross multiply. 1 times x will equal 400 times the tan of 31 degrees. So we go to our calculator. 400 times, now I guess we should make sure we're in the right mode, and I'm in degree mode, so we can finish this off. 400 times the tan of 31, there's the width of the river. 240 to the nearest meter would be 240 meters. Okay? So on the next page, a pilot starts his takeoff and climbs steadily at an angle of 12.2 degrees. Determine the horizontal distance. So horizontal is going straight across, so that's what x is. It's like measuring the distance along the ground. So we want to determine that distance the plane has traveled after it's climbed 5.4 kilometers along its flight path. Answer to the nearest tenth of a kilometer. So we want to find out what x is. We start though by labeling the sides of the triangle. Side across from the right angle is the hypotenuse. We're given that 12.2 degree angle, so we're going to use that. The side across from that is the opposite. Third side is the adjacent. In this case, we're going to use the adjacent and the hypotenuse. We're not given the opposite, not asked to find it, not using it. So Jensen, what ratio is that? Tan? You better pop on that. Well, let's look back at the previous page. Which uses adjacent and hypotenuse? Which uses adjacent and hypotenuse? Cosine. So what else does this tell us? That you owe me a pop. We have to use cosine ratio. The cosine of the angle, which is 12.2 degrees, equals. I wonder if you'll pay before Keen pays. Because I take off 10% of your mark for each pop that you owe me, Keen, and you owe me 5. So your mark would drop by 50% if you don't pay up. He'll be in the negatives. He'll be in the negatives. Yeah. Okay, so order matters. It tells us that it's adjacent on top, hypotenuse on the bottom. So x on top over hypotenuse, which is 5.4 on the bottom. Make both sides a fraction so we can cross multiply. 1 times x will equal 5.4 times the cosine of 12.2 degrees. So we go to our calculator to figure out what that is. 5.4 times the cosine of 12.2. So to the nearest tenth of a kilometer, that plane would have traveled 5.3 kilometers along the horizontal. Because the angle is so small, 12.2 degrees is pretty small, the distance along the base of the triangle is very close to the hypotenuse. But it can't be the same as the hypotenuse because the hypotenuse always is the longest side. So sometimes you're going to have to draw your triangle, but we're always going to start with the right triangle because if you don't have a right triangle, you can't use the trig ratios. So in this case, a ladder is leaning against a wall, and it forms an angle of 63 degrees with the ground. So that's the angle between the ladder and the ground, which has to be at the bottom. Okay, Kenzie? Do you want to bet a pop on that, Kenzie? Well, I didn't ask a question, so you can't. How far from the wall to the nearest meter is the foot of the ladder? So we're looking for x, the distance between the foot of the ladder and the wall, if it reaches 4 meters up the wall. So that's the height of this triangle. And you could definitely, if you wanted to, extend this side. It doesn't change how you do it, but you can only use the parts of this diagram that involves a right triangle. So now we need to label the sides of the triangle. Side across from the right angle is the hypotenuse. We're going to use this angle of 63 degrees. The side across from that is the opposite. The third side is the adjacent side. So Olivia, which two sides will we use here? Yeah, the opposite and the adjacent. We're given the opposite, it's 4 meters, and we want to find the adjacent. We're not given the hypotenuse, not asked to find it. So Peyton, what ratio uses opposite and hypotenuse? Opposite and adjacent, I should say. 10. What will our equation look like, Peyton? Because that's the next step. We need to write the equation. Tan of 63 degrees equals what? X over 4? Make up your mind. Is that right, Keen? Because tangent is opposite over adjacent. That's what the definition tells us. Make both sides a fraction, cross multiply. So it'll be x times the tan of 63 degrees equals 1 times 4. Now what, Brooklyn? Now what? You need to get x by itself. How do we get x by itself? Why can't you put your phone away? Huh? Jan? Divide both sides by tan 63. And that'll give us x by itself. So we're asked to write this to the nearest meter. 4 divided by the tan of 63. So that's approximately 2 meters. That's how far the foot of the ladder is away from the base of the wall. Number 4 says a guy wire supporting a cell phone tower is 24 meters long. So if you're driving on the highway or even some places in town, many towers have guy wires. So it's cable that's connected close to the top of the wire, or the tower, I should say, and then it's fastened to the ground at some point away from the base of the tower. It just supports the tower, especially in case of wind, which I know never happens here in Grand Prairie, but if it did, it would help support the tower so it basically doesn't fall over. So that's what a guy wire is. But we can start by drawing a right triangle, because unless we have a right triangle, you cannot use your trig ratios. And obviously, the hypotenuse would represent the guy wire. And we're told that the guy wire is 24 meters long. And the wire is attached at a height of 17 meters up the tower. So that's the height of the triangle. We want to know the angle that the wire forms with the ground. So where do you think that is, Liam? Yeah, it'll be at the bottom. It's where the wire meets the ground. Okay, the one at the top will be where the wire meets the tower. We want to know the angle that the wire forms with the ground. So that is the angle at the bottom, because that's where the ground is. Next, we label the sides of the triangle. Side across from right angle is the hypotenuse. We want to find angle theta in this case. And you could let that equal anything. I used theta. You could put x in there if you wanted to. It doesn't matter. For any variable. But the side across from the angle that you're looking for is the opposite. The third side is the adjacent. So what ratio will we use here, Jensen? You're a sinner? You want to bet a pop on that? Huh? Okay, we're even now. Because it is the sine. Only sinners say sin. So the sine of the angle theta that we're looking for, and now again the order matters. The definition of sine is that it's opposite over hypotenuse. It has to be 17 on top and 24 on the bottom. Allie, do you remember how we find theta? That'll give us a decimal, but that's what the sine of theta equals, not theta. That's right. You have to go second function sine. Sine to the negative 1 of 17 over 24. So second function sine of 17 over 24. 45 degrees. That's the angle that the guy wire makes with the ground. Okay? So, one more day of this stuff tomorrow. quiz on Friday, and I will also give you guys your review. I'll give that to you now, that you can start working on for your exam, which will be happening on Tuesday. And that will cover chapters 1, 2, and 3. Okay? So what you can work on for practice, and I will post these solutions on Google Classroom. This one does not have to be handed in, but the one from yesterday, that worksheet out of the package does. You can work on those questions. And again, I will post the solutions to Google Classroom so you don't have to memorize or don't have to hand this one in. But you should do it for the practice. It's going to help you on your quiz on Friday as well as your test next week. So again, remember those important dates. Friday's the quiz on Chapter 3. Tuesday's the Unit 1 exam, Chapters 1, 2, and 3. Your final exam is Monday, June 19th, here in this room at 8:30 in the morning. Also next Friday, June 9th, the last day to hand in any missing assignments. After that, they go in as zeros. Your marks will go down. No exceptions, no extensions. I had lots of warning that this was coming. So don't leave a bunch till the night before, because if something happens and you don't get a chance to do it, I'm not accepting them late. Okay?